Imagine this. Mars is a planet that billions of years ago could have been a second Earth, complete with flowing rivers, expansive lakes, and possibly even a vast northern ocean covering 1/3 of the surface. Today, it stands as a freezing, radiation-blasted desert with a paper-thin atmosphere, and the National Aeronautics and Space Administration still cannot fully explain 7 profound mysteries that completely challenge everything we thought we knew about the Red Planet. These are not wild theories or conspiracy ideas. They come straight from peer-reviewed data collected by orbiters, landers, and rovers. Are you ready for the truth that rarely makes it into the official press releases? Stay until the very end, because the final mystery could forever change how you see the history of life in the solar system, and why Earth remained habitable while its neighbor did not. Mystery number 1 is why Mars has 2 completely different faces, known as the crustal dichotomy. But this doesn't make sense at all. The northern hemisphere, dominated by the vast Borealis basin, is one of the flattest and smoothest places in the entire solar system, sitting 4 to 8 kilometers lower than the south on average. In contrast, the southern hemisphere is packed with ancient, heavily cratered highlands where the crust is twice as thick, reaching up to 60 kilometers in places. The total relief difference reaches 5 to 8 kilometers, sharper than any other boundary on a terrestrial planet. In simple terms, half the planet shouldn't look like this, but it does. For decades, scientists argued over 2 competing ideas: a single massive asteroid impact early in the planet's history that excavated the north, or internal planetary forces driven by mantle convection. And that's where the problem begins. Data from InSight seismometer, which operated from 2018 to 2022, revealed that the mantle beneath the southern highlands is hotter, with stronger convection currents. Seismic waves from Mars quakes travel differently across the 2 hemispheres, confirming greater crustal thickness in the south. This strongly supports an internal origin for at least part of the dichotomy. Yet the National Aeronautics and Space Administration still has no complete explanation for why one half of the planet sank dramatically, while the other remained elevated and preserved its ancient cratered terrain. The exact timing and full mechanism remain open questions after years of modeling and seismic analysis. Scientists thought they had the answer figured out with impact models, but InSight turned the entire picture upside down. And this breaks everything we thought we knew with mystery number 2, the baffling behavior of methane on Mars. Picture this. The gas appears and disappears, almost like magic. In 2003, the European Space Agency's Mars Express became the first spacecraft to detect trace amounts of methane in the Martian atmosphere. Later, the National Aeronautics and Space Administration's Curiosity rover inside Gale Crater recorded clear seasonal spikes reaching up to 21 parts per billion during southern summer, followed by an almost total disappearance to below 1 part per billion. Methane should remain stable in Mars's thin carbon dioxide atmosphere for roughly 300 years, according to standard photochemical models. Yet it vanishes within weeks or months. No model explains this. The ExoMars Trace Gas Orbiter, launched specifically to hunt trace gases from orbit, starting in 2016, detects almost none at higher altitudes, while Curiosity consistently sees it right at the surface. Possible sources include biological activity from subsurface microbes, geological releases from serpentinization of rocks, or even ancient deposits being uncovered by dust storms. Ultraviolet light, dust chemistry, and unknown destruction mechanisms break it down far faster than models predict. The National Aeronautics and Space Administration has openly stated in multiple mission updates, including the 2018 and 2021 science team reports, that the methane mystery remains unsolved and represents one of the most puzzling aspects of current Martian chemistry. But here's the part scientists can't explain. Nothing fully accounts for the observations. Here's where things start to feel troubling with mystery number 3, which asks whether rivers, or at least seasonal flows, are still active on Mars right now. This shouldn't exist. Since 2011, the high-resolution imaging science experiment camera aboard the Mars Reconnaissance Orbiter has captured thousands of dark, narrow streaks on steep slopes. These recurring slope lineae are 0.5 meter to 5 meters wide and stretch hundreds of meters long. They appear every spring on equatorial and mid-latitude southern slopes, lengthen over just a few weeks, and fade again in winter when temperatures drop. In 2015, the National Aeronautics and Space Administration announced they were probably salty brines because hydrated perchlorate salts were detected in the same locations via spectral analysis. And that's where the problem deepens. Newer research from 2019 through 2025, however, shows that many of these flows match dry, granular avalanches of dust and sand far better, driven by seasonal wind or thermal changes. There is still no direct spectral proof of liquid water persisting on the surface today, and laboratory simulations struggle to keep brines stable under current Martian pressure and temperature. The exact mechanism continues to spark intense debate inside the National Aeronautics and Space Administration and European Space Agency teams. Liquid water mixed with salts, or simply dry sand sliding downhill. The National Aeronautics and Space Administration first declared it was likely water, and now the story is far more complicated after years of additional high-resolution imaging. And it only gets harder to explain with mystery number 4, where the ancient atmosphere and oceans of Mars actually went. But this shouldn't be possible after everything we see. Evidence of ancient rivers, deltas, lake beds, and a possible northern ocean covering up to 1/3 of the planet is overwhelming from orbital mapping and rover traverses. Yet climate models for early Mars, when the young sun was 30% fainter, cannot easily explain how a thick carbon dioxide atmosphere could have kept the surface warm enough for widespread liquid water. Curiosity drilling into Mount Sharp layers and Gale Crater recently confirmed siderite, an iron carbonate mineral, making up 5 to 10% of some sedimentary rocks. That is the clearest sign yet of a major active carbon cycle operating billions of years ago. Earlier missions found almost no carbonates, which should have formed everywhere if the atmosphere had been thick and wet for extended periods. Mars atmosphere and volatile evolution orbiter data from 2014 onward proved that solar winds stripped away the atmosphere once the global magnetic field died, with roughly 90% of the original atmosphere lost to space over time. Still, the precise quantities of water and gas lost, the exact pathways they took, and where any remaining reservoirs might hide underground do not fully add up in current models. Scientists found a new key mineral in the rocks, and the mystery only grew deeper with each new data set. This gets almost disturbing with mystery number 5, the origin of Phobos and Deimos, Mars's 2 tiny moons. And this breaks every rule. These are the smallest moons in the solar system. Phobos measures 22 kilometers across at its widest, and Deimos only 12. Their orbits are almost perfectly circular and aligned with Mars's equator, which is unusual for captured objects. Their densities are extremely low, matching loose rubble pile asteroids of the primitive C-type. 3 main ideas exist. They were captured from the asteroid belt, formed as debris from a giant impact on early Mars, or were fragments of a larger moon that broke apart. None of these fully explain the moon's chemistry. Their nearly circular orbits, low density, and the fact that Phobos is slowly spiraling inward toward Mars at a rate of 2 centimeters per year. Both the National Aeronautics and Space Administration and European Space Agency continue to list the origin of Phobos and Deimos as one of the biggest unsolved questions in the entire Mars system, with future sample return missions like the proposed Martian moon's exploration by the Japan Aerospace Exploration Agency, hope to bring back material that could finally settle the debate. They are simply too strange in their properties to be ordinary satellites, yet every hypothesis leaves key observations unexplained. But what they discovered next is truly disturbing and leads us into mystery number 6. The organic molecules that Curiosity and Perseverance have been discovering in surprising abundance. This shouldn't exist on a dead world. Inside Gale Crater, Curiosity's sample analysis at Mars Instrument identified a wide variety of organic compounds, including thiophenes, benzene, and long-chain hydrocarbons, some of which were once considered possible only from biological sources. Perseverance in Jezero Crater has located complex organics and potential biosignature patterns preserved inside ancient lake rocks and river deltas. One particular sample, collected from an area nicknamed Sapphire Canyon, stands out in peer-reviewed studies as containing the strongest hints yet of ancient microbial activity through carbon isotope ratios and mineral associations. Every scientist involved, including those from the Perseverance team, stresses the same point. These detections are not proof of life. Completely non-biological chemical pathways, such as hydrothermal vents or meteoritic delivery, can also produce the same molecules under the right conditions. The National Aeronautics and Space Administration's clear position, repeated in 2024 and 2025 updates, is that only samples returned to Earth laboratories can settle the question once and for all through advanced laboratory analysis unavailable on the rover. This could be the first real evidence of ancient life, or it could be nothing more than ordinary prebiotic chemistry preserved for billions of years. And this is where everything connects in the most chilling way with the 7th and final mystery. Why did Mars lose its global magnetic field and turn into a desert? But here's the part that turns everything upside down. Roughly 4 billion years ago, the dynamo inside the planet's core shut down permanently. Only the southern crust still holds faint remnants of that ancient magnetic field in the form of crustal magnetization detected by orbiters. Without a protective magnetosphere, solar wind gradually stripped away most of the atmosphere at a rate measured precisely by Mars' atmosphere and volatile evolution. The orbiter has mapped this escape process in precise detail, showing ions being picked up and carried away into space. Yet no one knows exactly why the dynamo failed at that specific moment in history. Why the South kept strong magnetic anomalies, while the North shows almost none. Or how this single event triggered the planet's rapid shift from a wet, Earth-like world with a thick atmosphere to the dry, cold wasteland we see today. The samples that future Mars sample return missions hope to bring back from Jezero Crater are expected to hold the final clues about the timing and causes, assuming the program continues despite ongoing budget pressures and technical challenges. The National Aeronautics and Space Administration scientists openly admit these 7 mysteries still lack final, definitive answers after 2 decades of intensive exploration. If even one of these mysteries is true, Mars wasn't just habitable. It may have been alive once, and we arrived too late to see it. Drop a comment below and tell us which mystery surprised you the most and why. If you want more in-depth coverage, like this video for a follow-up episode on 10 additional hidden facts about Mars that the National Aeronautics and Space Administration rarely highlights in public briefings, subscribe, hit the bell, and we will see you on the next journey to the Red Planet. Thanks for watching. Keep looking up, and remember that the universe still has plenty of secrets waiting to be uncovered.